This is a video on the limit comparison test. The question states, determine if the series converges or diverges. We have the summation from n equals 0 to infinity of n squared plus 2n plus 5 over n cubed minus n squared plus 1. So here what we want to do is find a series that we know about that we can compare this unknown series to. And the technique is we look at the numerator and the denominator and we just focus on the terms that are the highest power in each. So in particular, n squared is the highest power term on the top and n cubed is the highest power term on the bottom. And n squared over n cubed is the same as 1 over n. So I'm going to compare with the harmonic series the summation of 1 over n, which we know diverges by the harmonic series test or the p-series test. So let's conduct the limit comparison test. We take the limit as n goes to infinity of an over bn, or n squared plus 2n plus 5, over n cubed minus n squared plus 1, that's an. And then our bn was a harmonic series, so the terms are 1 over n, and we divide. So division is the same as multiplying by the reciprocal. So I multiply. And then I multiply the n through on the top, and I guess the 1 through on the bottom. And I get the limit as n goes to infinity of n cubed plus 2n plus 5 over n cubed minus n squared plus 1. There are different ways of finding this limit. We could have used L'Hopital's rule, but I think it's a little easier at this point just to divide by n cubed on the top and the bottom. So I do that, and I get 1 plus 2 over n squared plus 5 over n cubed over 1 minus 1 over n plus 1 over n squared. The reason for dividing is we're taking a limit as n goes to infinity, and that way these lower order terms zero out. And what we're left with is 1 plus 0 divided by 1 minus 0 plus 0. And that's as n goes to infinity. And that's just 1 over 1, or just 1. That's what I want, because when we're using the limit comparison test, we just want to make sure that the limit as n approaches infinity of an over bn is not 0 and not infinity. And 1 isn't either of those. So that tells us we can use a limit comparison test, and that says that our series does the same thing as the series the summation of 1 over n does in terms of convergence or divergence. So in particular, remember the summation from n equals 1 to infinity of 1 over n diverges either by the p-series test with p equals 1 or just it's the harmonic series. And we can conclude that our series, a summation from n equals 0 to infinity of n squared plus 2n plus 5 over n cubed minus n squared plus 1 diverges by the limit comparison test. And I'm done with the problem.